Welcome to a new video which is about limits in horizontal asymptotes. In this video I will explain the definition and then solve instructive examples regarding the subject. If this is your first time here and if you want to support this channel, don't forget to subscribe, click on the bell to turn on the notifications to be aware of the upcoming videos. We have a lot to cover, so let's get started. And we have a definition, guys, and it says line y is equal to b is an horizontal asymptote of the graph of the function y is equal to f of x, where limit when x goes to infinity of f of x is b, or limit when x goes to negative infinity f of x is equal to b, guys. So as we see here, b is a line and we have a sample here. Okay, for example, y can be equal to b1 or y can be equal to b2. Those are different lines, but they have to be parallel to the x-axis. So we can say that horizontal asymptotes are parallel to the x-axis, and as we see in this graph. And let's take a look at examples to understand the topic better. And we have an example, guys, and it says find the horizontal asymptote of y is equal to 5 plus 4x divided by 2x plus 1. I just put the graph of the function here, but actually without looking at the graph, we can easily find out the solution as well. And to find the horizontal asymptote, we have a remark here, guys, and it says ratio of coefficients of leading terms. Leading terms means the highest powers of numerator and denominator. For example, in this question, the leading term of the numerator is 4x. Why? Because the highest power is x and its coefficient is 4. And if you look at the leading term in the denominator, it is 2x, guys. Coefficient is also 2. So we're going to have 2x as a term. And if we look at the limits, let me write it here, limit when x goes to positive infinity of 5 plus 4x divided by 2x plus 1. And as you can see, we have 4x here, we have 2x here. And if you look at their coefficients, we have 4 divided by 2, which is going to be 2, guys. So limit when x goes to positive infinity, then the limit is 2. Actually, if it goes to negative infinity also, okay, when x goes to negative infinity, still we're going to have 2. And we can actually see it over the graph as well. If you approach positive infinity over the x-axis, as you can see, the function is going to 2, guys. So the function is approaching to, this line is a 2 actually, because it's small, you may not see it exactly. And if you approach negative infinity over the function, okay, and as you can see here, it passed the x-axis and then it approaches to 2 as well. So either you go to positive infinity or you go to negative infinity, still we're going to have 2 as an horizontal asymptote as we see in this question. And let's take a look at the next example. And in this question, guys, it says find the horizontal asymptote of the following function. Again, we have y is equal to x cubed minus 3 divided by, in the absolute value, x cubed plus 3. I just put the graph of the function here, but actually without looking at the graph, we can easily solve the question as well. But let's solve the question by just considering the function that is given to us. So limit when x goes to positive infinity, guys. X cubed minus 3 divided by. When x goes to positive infinity, the inside of the absolute value is positive, guys. So the x cubed comes out as it is. So it's going to be x cubed plus 3, guys. And again, we will take a look at the leading terms of the numerator and denominator. The leading term is x cubed and the leading term is still x cubed in both numerators and denominators. And if you look at their coefficients, they are 1. So we're going to have 1 divided by 1, which is 1, guys. So we can say that limit when x goes to positive infinity, the horizontal asymptote is 1. Actually, if you look at the graph also here, if you approach over the function to the infinity, and as you can see, the function is approaching to y is equal to 1. So we can say that there is an upper limit as a line, which is called horizontal asymptote, and that is equal to 1, guys. And if we write limit of x cubed minus 3 divided by, and now when x goes to negative infinity, the inside of the absolute value is negative. To make it positive, we just multiply it by a negative to make it positive. So x cubed comes out as negative x cubed plus 3, guys. And now if you look at the leading terms, again we have x cubed in the numerator and negative x cubed in the denominator. But if you look at their coefficients, in the numerator it is 1, in the denominator it's negative 1. So if you divide 1 by negative 1, of course we're going to have negative 1. That means, guys, when x goes to negative infinity, the horizontal asymptote is negative 1. Actually, again, if you approach negative infinity over the function, okay, when x goes to negative infinity, as you can see, the function is approaching exactly y is equal to negative 1, this line. Okay, if you think this is a line, it's going to approach to this line. So we can say that there are two asymptotes. One of them is positive 1 and the other one is negative 1. And if you analyze the question, the powers of the numerator and denominator, they are same, but we have two horizontal asymptotes. In the previous question, even though they have both numerators and denominators same power, in that question there was just one horizontal asymptote, but here we have two horizontal asymptotes. So just pay attention on such cases, guys. It is possible to have one or two horizontal asymptotes in such questions. And we have a new question, guys, and it says find the horizontal asymptote of the following function where the function is x squared minus 4 divided by x minus 5. And as you can see here, leading term is x squared in the numerator and the leading term is x in the denominator. So if we write limit when x goes to infinity, I will take the numerator in x parentheses, and once you do it, we're going to have x minus 4 divided by x divided by, guys, in x parentheses, I have 1 minus 5 divided by x. So x values will gone, and when x goes to infinity, that value is going to go to 0, guys, because 4 divided by infinity is 0. 5 divided by infinity is 0 as well. So we're going to have x divided by 1, and when x goes to infinity, that is infinity, guys. So let me write it here. Limit when x goes to infinity, x is infinity, of course. When x goes to negative infinity, it's going to be negative infinity, okay? We can see it also over the graph when x goes to positive infinity over the function, and as you can see, y value is going to positive infinity. When x goes to negative infinity over the function, y value is going to negative infinity. But as you can see, there is no line, okay? Because there is no line, such a line which is parallel to the x-axis, then we can say that there is no horizontal asymptote. Yes, it looks like there is a line, but it is not parallel to the x-axis. So there is an asymptote which is called oblique asymptote, and which is what we're going to look at in the next topic. But as an horizontal asymptote, there is no such an asymptote in this question, guys. And let's take a look at our last question. In this question, guys, we have the function as x to the power of 4 plus 5x minus 1 divided by x to the power of 5 minus 3x. And as you can see, the leading terms are x to the power of 4 in the numerator and x to the power of 5 in the denominator. So if we write limit when x goes to infinity, guys, and I'm going to take both numerator and denominator into the x to the power of 4 parentheses, okay? And then once we do it, we're going to have 1 for x to the power of 4 plus for 5x. To obtain 5x, I need to put here 5 divided by x cubed. Okay, because when you multiply x cubed by x to the power of 4, then we're going to have just x. So with that 5, it's going to be 5x. Minus, to obtain negative 1, I need to put here 1 divided by x to the power of 4. And if you take the denominator to the x to the power of 4 parentheses, then we're going to have x here minus 3 divided by x to the power of 3, guys. And now those x to the power of 4 values are gone. When x goes to infinity, 5 divided by infinity is going to be 0. A number divided by infinity is going to be another 0. A number divided by infinity is another 0. So what is left over is, we can summarize this as limit when x goes to infinity, we have 1 divided by x left over. And it doesn't matter when x goes to negative infinity or positive infinity, 1 divided by positive infinity or negative infinity is going to be 0, guys. So we can see the same thing over the graph as well. When you approach positive infinity over the function, okay, as you can see, the function is approaching to y is equal to 0. Similarly, over the function, when you approach negative infinity, okay, and as you can see, y is approaching again 0. So we can say that yes, horizontal asymptotes exist, and that is 0. It doesn't matter when x goes to positive infinity or when x goes to negative infinity. And as you can see, the power of the denominator is greater than the power of the numerator. And in such cases, always, guys, you obtain 0. So just keep it in mind that if the power of the denominator is greater than the power of the numerator, and when x goes to positive infinity or negative infinity, we're going to have 0 in such limits. And that was the last question in this video, guys. If you have any question, you can put them in the comment section below. Thank you for watching, and hopefully see you in the next video.